Yeah. So we completed with this multipliers and parallel subtractors. No, today we'll start the new topic uh, that is nothing but multiplexers. Okay. So multiplexers will start. Okay. This is one of the important topic in the digital. Okay. One second. Is it visible? No. This board. Is it visible? No. Okay. Okay. So we'll see the multiplexer. So multiplexer is nothing but what it have how many inputs? It have 2 power n inputs and only one output. Okay, only one output and n selection lines. Okay, n selection lines, and this is nothing but we can implement. That means this is nothing but we can call as many to one circuit. Okay, many to one circuit. Okay, at a time any one of the input is connected. Okay, that's why we call as many to one circuit, or we can call as data selector also. Data selector. Okay, we can call as data selector. Okay, data selector, or we can call as universal circuit. Okay. So why we call this as universal circuits? So in the gates we have seen universal logic gates. What are the universal logic gates? Can anyone say? Yeah, NAND and NOR. NAND and NOR. Why we call this as universal logic gates? Why we call this as universal logic gates? NAND and NOR.
Sir, voice is not audible.
One second. Now is it audible? So NAND and NOR are nothing but universal logic gates. So these are nothing but universal logic gates. Why? Because so we can implement any of the gate. Okay, we can implement any of the gate by using NAND and NOR gate. Okay, so that's why we call as universal logic gates. Okay, so here we can implement any of the combination circuit by using MUX. That's why we call as universal circuit. That means we can implement you can implement full adder, or we can implement full subtractor. Okay, we can implement comparator. Any of the combinational circuit we can implement by using multiplexer. That's why we call as universal circuit. Or we can implement some Boolean equation also. So we can implement any Boolean function using this MUX multiplexer. Okay, so that's why we call as this as universal circuit. Okay, so if you see the basic block diagram of this MUX, so here you have so how many inputs are there? So total you have 2 power n inputs and one output. And how many selection lines? You have n selection lines.
In selection lines.
Okay, so that n selection. So that means multiple inputs are there. At a time any one of the input is connected to the output, and depending on the selection line. So here if you take n equal to 2 you take. Okay, n equal to 2 means which MUX you will get? 2 cross 1 MUX. N equal to 2 cross MUX. Okay, n equal to 3 if you take. Okay, and this is nothing but 8 cross 1 MUX you will get. Okay, 8 cross 1 MUX. Okay, and next n equal to 4 if you take, so you get 16 cross 1 MUX. Okay, this is MUX. Okay, so first we'll see 2 cross 1 MUX. So 2 cross 1 MUX. First if you see 2 cross 1 MUX. So if you see 2 cross 1 MUX, somebody is getting disturbance. Please mute yourself. Somebody is getting disturbance. Yeah. So if it is 2 cross 1 MUX, how many data pins are there? So that means 2 inputs are there, and one output will be there, and one selection line is there. Okay, Okay, so here there is one enable pin and selection line and output. selection line and output. Okay, so enable is acting like a this enable pin is nothing but suppose if it is 2 cross 1 mux, enable pin is acting like a switch. Enable pin is acting like a switch. So that means how many inputs are there? So like you have two inputs, I0 and I1, I0 and I1, and how many outputs? One output. And how many selection lines? One selection line. Okay, so this is 2 cross 1 mux. 2 cross 1 mux. Okay, so that means enable pin. So here you have one more pin, that is enable pin. Enable pin is nothing but it is acting like a switch. It is acting like a switch. Okay, there are two types of enables will be there. One is active high enable. This is active high enable. So active high enable is nothing but what? When E equal to 1, it will be active. It will be active. When E equal to 0, it will be deactive. Deactive or inactive. Okay. So here this this is active low enable. Active low enable is nothing but what? When E equal to 0, this will be active. Okay, and when E equal to 1, this will be inactive. Okay, this will be inactive or inactive. Okay, so this is directly I given. This is nothing but which signal? Active high enable signal. Okay, active high enable signal. So now see, so that means when enable equal to 0, when enable equal to 0, whatever may be the selection line, whatever may be the selection line, okay, what is the output? Output equal to 0.
1, sir.
Output equal to 0. Output equal to 0. So that means enable equal to 0. So this will be this mux will be in inactive state. Mux will be in inactive state. Okay. Now when enable equal to 1, so when enable equal to 1, selection line is 0. So depending on the selection line, suppose if selection line is 0, so which is connected to the output? I0 is connected to the output. Okay, so that means this is nothing but what? I0. I0. Okay, so this is nothing but I0. When enable is 1, selection line is 1. Okay, so which is connected? I1 is connected to the output. I1 is connected to the output. At a time, any one of the input is connected to the output. Okay, so here this is nothing but I1. This is nothing but I1. Okay, now you can get the expression. What is this expression? Why I0? That means what is this expression? Tell me. E is 1. That means this is nothing but what? E, and S is 0. This is nothing but S bar, S bar, and I0. S bar I0, and S bar I0. And next, what is this? E, E, ES I1. I1. Okay, so plus OR operation. That means Y you can write as, this is Shannon's equation. That means E or output equation of E S bar I0 plus ES I1. I1. Okay, ES I1. Okay, so I can draw the logic diagram. What are the inputs are there? What are the inputs are there? One is E. Okay, one is E. Next is, tell me. One is yeah. First you take a selection line. Selection line with an inverter. With an inverter. Okay.
So selection also input, sir?
Yes, selection is also input. Selection line, this is input, and this is input, and this is output. Okay. So this is Y. Okay, this is Y. Output Y. Okay, output Y. Output is 1 bit. Output is 1 bit. Okay, so here this is I0, and this is nothing but I1. Okay, I0 and I1. So now based on this you draw the circuit. That means first E, next S bar I0 connected with which gate? And gate. Okay, and next ES I1. Okay, I1 connected with the AND gate. Okay,
And
these two are connected with the
XOR gate.
OR gate. These two are connected with the OR gate. Here plus is there. Plus is there. Plus OR gate. Okay, OR gate. Okay. Is it fine? Do you understood?
Yes, sir.
Huh? Okay. This is the you can note down. Please note down.
Sir, shall I note down?
Yes, yes, yes. Please note down. 1 second, 1 second. Okay, note down.
Sir, shall I note down?
Yes, note down, note down. Yes, yes, note down. Please note down.
Yeah.
Yeah. Next, I want to implement 4 cross 1 MUX. Okay, I want to implement 4 cross 1 MUX. How many inputs are there? 4 inputs. Okay, 4 inputs. And how many selection lines? 2 selection lines. And 1 output. Okay, 1 output. Okay. So here, so the block diagram will look like this. 4 inputs are there. So this is 4 cross 1 MUX. 4 cross 1 MUX. Let us take the inputs are, yeah.
How to take two selection lines?
If it is 2 power n inputs, 1 output, okay, n selection lines. Okay, so that means 4 cross 1 MUX means this is, you can represent as what, 2 square cross 1. These are the selection lines. This power is there, no? So power is there means power is the selection line. This is the selection line. Okay, this is the selection line, and 2 power n is nothing but the input, and this is the output. Okay, suppose if it is
Okay, sir.
8 cross 1 MUX, how many selection lines?
3 selection lines.
If it is like 64 cross 1 MUX,
6 selection lines.
yeah, 2 power 6, 2 power 5 is 32, 2 power 6 is 6 selection lines. Okay, based on that you need to find out the selection line. So this is I1, I2 and I3. Okay, I3, and this is the output. Okay, 2 selection lines. So 2 selection lines, S0, S1. You take S0 and S1. Okay, S0 and S1. Okay, S0 and S1. Okay, I think you can draw the truth table. So that means one is enable pin, and next S1, S1, and next is S0.
It's not.
Okay, and output is Y. Okay, output is Y. So when enable pin is 0, whatever may be the S1 and S0, the output is what? 0. The output is 0. Okay,
0.
okay, output is 0. Okay, when enable pin is 1, okay, enable pin is 1. Okay, 1 second.
0, sir.
Enable pin is 1. So that means how many possible combinations? 4 possible combination: 0 0,
8.
0 1, 1 0, and 1 1.
10.
1 1. Okay,
1 1.
I'm getting disturbance. Someone from which one? Anila. Anil. Okay. Something you are talking means please mute. Something you are talking with others, please mute. Okay. So see here. So S1 and S0. This is nothing but I0, and this is I1, and this is I2, and this is I3. Depending on the selection line. See here. So that means when selection line is 0 0, which one will be connected? I1 will be connected. Okay, and when selection line is so if you see selection line is 1 1, which one will be connected? I1 will be connected. So 1 1, which one will be connected? I1 will be connected. 0 1, when it is 0 1, I1 will be connected. Okay, and when the 1 0, so 1 0 means I2 will be connected. Okay, I2 will be connected, and 1 1 means what? I3 will be connected.
1
I3 will be connected. Okay, so what is the Shannon's equation? What is the output equation or Shannon's equation? What is Shannon's equation? S1 bar, S0 bar,
S1 bar is
I0
plus
plus
I0.
S S1 bar.
S0 bar.
This you need to take as this is MSB. Okay, this is S1 is MSB, and this is S1 and S0. You need to take like this, S1 and S0. Okay, and 0 1,
Sir, S0 bar.
S1 bar, S0, 0 1. You need to take like this. Selection lines are, you need to take S0 is LSB and S1 is MSB. Okay, what is this? I1 plus 1 0, S1, S0 bar, I2, plus S1 S0 I3. Okay, I think, can you draw the logic diagram?
Yes.
Can I draw the logic diagram?
Yes.
Yeah, you draw the logic diagram. Enable pin is also there. Okay, enable pin is also there. Okay, so that is optional. Okay. So here with respect to enable pin also I am drawing. So this is what S1 S1 connected with an inverter. Okay, and S0. So much disturbance is coming. Where, Anil? Okay, okay. Disturbance is coming. Just mute yourself when you are responding. S1 and S0. Okay, S0, and it is connected with the inverter. And what are the inputs? I0 and next I1, I2, and next I3. I3. Okay, so you can connect. So what is what is first one? S1 bar,
S1 bar, S0 bar.
S1 bar, S0 bar, I0 connected with the AND gate. Okay, and next S1 bar, S0.
S1 bar, S0.
S1 bar, S1 bar, S0, S0 connected with the I1 connected with the AND gate. Okay, and next so here if you see, tell me
S0 bar.
here I am extending. This is here I am extending. So if you see, S1 S0 bar,
S1
S1 S0 bar and connected with the I2, okay, and I3 S1 and S0 I3 connected with an AND gate. These all are connected with the
OR gate.
Connected with OR gate. These all are connected with OR gate. This is output Y. Based on the Shannon's equation, I got this. Okay, I got this. Okay.
Sir, this is called Shannon equation, sir.
Yeah, this one is Shannon's equation. This is nothing but Shannon's equation. This is nothing but Shannon. So we call as Shannon's equation. Okay. Or we can call as output equation also. Both are same. Output equation of MUX. Okay. Output equation of MUX. Okay. You could note down. Your task is, you need to design 8x1 MUX.
Okay, sir.
Okay. You need to design 8x1 MUX. Okay.
Shall I note down this?
Yes. Note down.
So can you explain how you selected the select lines?
Means where you have doubt? Tell me.
Then in select lines, how you have selected?
Means actually here this is like S1 and S0. Okay. This S0 is nothing but LSB bit and S1 is nothing but MSB bit. Okay. When both both are 0 0, means you are asking the number of selection lines, sir. I didn't.
Yes, sir.
Number of selection lines means in general I told you, no, 2 power n cross 1 MUX.
Why not?
Okay, so that means this is nothing but what?
Selection lines.
Selection lines. So that means you have 4 cross 1 MUX. So if you are writing in terms of 2 power 2 square cross 1, how many selection lines?
Two selections.
2 selection lines. Okay, suppose if I consider 256 cross 1 MUX, how many selection lines?
8 selections.
2 per 8, no? 2 per 8. Okay, suppose 1024 cross 1 MUX, 2 per 10. So how many selection lines? 10 selection.
10.
Okay, now your doubt is clear, Shubhi Yadav?
Yes, sir. Clear.
Yeah, no doubt.
18 to 1 task.
Yes, this one is task. This one you need to design and you need to show.
Yes, sir. And the sir.
Yeah, tell me.
That you written 4 class and multiplexer. That is first one is S1 or S0, sir?
Means actually this is S1 and this is S0. Remember this S0 will be LSB, least significant bit, and S1 will be MSB. Okay, based on that only I am writing. See here, Shannon's equation. S1 bar, S0 bar, S1 bar, S0 bar. This is nothing but what? 0 0, and this is nothing but 0 1. Okay, 0 1,
01,
and this is 1 0
01,
and 1 1.
1.
Okay.
Okay.
Yeah, completed. Yeah, no.
Just wait.
Okay.
One minute.
Yeah. Where will you use this application of MUX? Can anyone say? Application of MUX. Hello. Application of MUX. Application of MUX. That means there are like multiple sources are there. You want to select only one single source. Okay. So multiple sources are there. Okay. Multiple sources means suppose you want to listen the means in communication also time division multiplexer frequency division multiplexer there you'll use uh, suppose in a real life application if you see you have like mp3 player. Okay, you have mp3 player. Okay, and you have laptop and you have digital satellite. Okay, and you have like digital mm, what we call digital cable tv. Okay, digital cable tv. These are multiple sources. From this four sources I want to listen the sound. Okay, so at a time I can't connect this all sources, no. At a time I can't connect this all sources. Okay, so this one I need to give it to a selector. Selector is nothing but what? MUX. Okay, selector is nothing but MUX. Okay, so if you connect to 4x1 MUX, so this is a selector. I am giving it to 4x1 MUX. Okay, so how many selection lines are there? Two selection lines are there, and this is connected to what? This is connected to single destination. Okay, what is the single destination? Suppose surround sound system is there. Okay, surround sound system. Okay, I want the sound from all this.
It is not visible.
Screen not visible. One second. Wait. Now is it visible? I will stop sharing and I will again. Now is it visible?
Yes, sir.
Okay. So that means if you connect to the surround sound system, that is like speakers. So that means here if you see, you can connect to the speakers. Surround sound system is what? Speakers. You can connect to the speakers. Okay, so you can connect to the speakers. Hello, you can connect to the speakers.
Speaker.
Okay, speaker. Okay. So this is nothing but speaker.
Okay.
So if you connect to the speaker, when it is like selection lines are, let us take B and A. When it is 0 0, which is connected? MP3 player is connected. When it is 0 1, which is connected? Laptop is connected. From the laptop also you can listen the songs. That is connected to the surround system. And from the, if it is 1 0, digital satellite will be connected. Okay, digital satellite will be connected. Okay, digital satellite card. Okay, that means you have like digital satellite system. No, nowadays we are using cable TV as digital that no. Okay, and if it is 1 1, digital cable TV will be connected. Set-up box, digital cable TV will be connected. Okay, so this is one of the application of MUX. So you have multiple sources, you want to connect a single source, so there you need to use MUX. Is it fine?
Yes, sir.
No doubt. Yes, no doubt.
Like this one of application, sir.
This is the application of MUX. Application of MUX. Yes, yeah, completed.
Sir, the single destination is there, sir. That is what, sir?
Which one?
Single destination. You return.
Single destination. Single destination means here multiple sources are there. Multiple sources are there, and single destination means this is only one single, no, one destination. This is source. These are nothing but source. Destination, single destination. Destination means we can use like digital surround system or speakers as a single. From the speakers you will get the output. Okay, these are the sources. These are the source. Okay, 1 second. Yeah, completed remaining.
Yes.
Okay, 1 second. Okay. So next, if I want to implement higher order mux by lower order mux, how to implement? Okay, implementation of higher order mux by lower order mux. Okay, by lower order mux. So how to implement? Okay, so you see, step one.
Sir,
Yeah. 1 second.
voice is not audible.
Now is it audible? Hello.
Yes, sir.
Step one.
Yes, sir. Yes, sir.
There is some network issue. Okay. Step one. If you see step one, calculate the number of muxes required by dividing higher order mux with lower order mux. Okay. Calculate number of muxes. Okay, number of muxes required. Okay, number of muxes required by dividing higher order mux by lower order mux. Okay, higher order mux by lower order mux. Okay, lower order mux. And step 2, what is step 2? Step 2 is continue till we get 1. Continue till we get 1. Okay. Step 3, add all number of muxes and connect. Add all number of muxes and connect. Okay, so here if you see, that means I want to represent 4 cross 1 mux by using 2 cross 1 mux. Okay, using which mux? 2 cross 1 mux. Okay, so 2 cross 1 mux. So how to implement? First, what you need to do? First, step 1, calculate the muxes required. So you need to calculate the number of muxes required by dividing higher order mux by lower order mux. So here what you need to do? What is higher order mux? 4. Here lower order mux is what? 2. So that means 4 divided by 2. This is equal to how much you are getting? 2. This is first stage. In first stage, how many muxes are required? 2 muxes are required. Okay, and after that 2 by 2, again 2 by 2, you are getting 1. This will come in second stage. Okay, so total muxes required. How many muxes are required? 2 plus 1. How many? 3 are required. Okay, so how to implement? So here I am implementing this mux. So 2 cross 1 mux. In the first stage, how many 2 cross 1 muxes are required? This is first stage. In the first stage, two 2 cross 1 muxes are required. Two 2 cross 1 muxes are required. Okay. So that means this is first 2 cross 1 mux, first 2 cross 1 mux, and this is second 2 cross 1 mux, second 2 cross 1 mux. Okay. So how many inputs? So here I0, I1,
I2,
I2, I2, and next I3. Okay. So these outputs are given to third mux. These 2:1 mux. Okay. This is second stage. Second stage. So this is third 2 cross 1 mux. 2 cross 1 mux. Okay. So this is second stage. In second stage, this is output Y. Okay. So first stage, common selection line will be there. What is that selection line? Let us take S1. Okay, S1. And next stage, what is the selection line? S0. S1 and S0. Like this also you can take. Is it fine? How? Yeah, tell me.
One more. Is there one more mux?
Why one more mux?
No, sir. That you are not mentioned now. Selection line.
This is selection line.
This one, sir.
Here selection line, common selection line. One selection line, two selection lines. Both are common for two muxes.
Okay.
Common muxes. Both are selection line. This selection line is.
I'm not asking. I am not asking about this one. Second 2 cross 1 mux is there.
Yes.
For that one selection line is required, sir.
One selection line. S0.
Yes, sir. Second mux, sir.
Common selection line was two muxes.
Okay.
Common selection line for two muxes. I am using common selection line for two muxes. S1 is the common selection line for two muxes. Okay. Suppose if it is like S1 and S0. Okay. So if you take the output is Y. Okay. So if it is 0 0, now you see. So 0 0. 0 0 means what? When it is 0, which is connected? I0 is connected. And when it is 0, which is connected? Y is connected to I1. Okay. And next if you see, next 0 1, which is connected? I1 is connected. Okay. Again this is 0 0, this is 1. 1 second. S1 it's not S1. Okay. S0 is 1, no? Okay, sorry. This is S0 and this is S1. S0 and S1. You need to take this as S0 and S1. Okay. S0 and S1. So when it is 0 1, S0 is what? 1, and so S1 is what? 1 second. S0 is what? S0 is okay.
S0 is 0.
S1 is 0. S1 is 0 means what? So this is connected. So S1 is 0. S0 is what? 1. S0 is 1. Okay. You need to take S0 and S1. Okay. Take S0 and S1. And suppose if it is 1 0. 1 0 means which is connected? I2. So 1 0. So this is S0 is 1 means this mux will be connected. So this will be connected. I2 is connected. And this is 0. 0 means what? So 1 0. S1. 1 second. S1. So S1. So this is connected. I think this should be connected. You analyze this. Okay. When it is 1 1, this is connected. When it is 1 1, this is connected. Okay. Depending on the selection line, any one of the input is connected to the output.
For I2 and I3 same, sir.
For
I2 and I3. They are connected to Y.
1 second. I will say. Don't worry. 1 second. Yeah, I'm drawing the MUX. Okay, so I'm drawing the MUX. 1 second. Add all the number of MUXs and connect one connect. Okay, so here if you see, so this is 1 2 cross 1 MUX, 1 2 cross 1 MUX, and next this is 1 2 cross 1 MUX. Okay, so 1 2 cross 1 MUX, and the inputs are nothing but I0, I1. Okay, and here the inputs are I2 and I3. Okay, so let us take the common selection line as S0. Okay, and next select, so this is connected.
One more.
So one more MUX, and this is nothing but S1. This is nothing but S1. Okay, so this is nothing but S1. So if you take which is MSB and which is LSB, you tell me.
S0 is MSB, sir. LSB.
S0 is LSB. Okay, S0 is LSB. Okay, so S1 is MSB. So S1 and S0 you need to take, and the output is what? Y. Output is Y. So when it is 0 0, which is connected?
I0 is connected.
I0 is connected. So 0. So this is 0 and this is 0. Okay, so I0 is connected. So I0 is connected like this. I0 is connected. Okay, and next 0 1 0 1. So see here, I1 is connected like this. So I1 is connected like this line. Okay, so that is nothing but what? 0 1 0. Okay, 0 1. 1 second. Next 1 0.
I2, sir.
I2. So I2 is connected. Okay, I2 is connected like this. Okay, 1 1. I3 is connected. Okay, I3 is connected. So like this we need to implement a higher order MUX by using lower order MUX. Is it fine?
Yes, sir.
Yeah, no doubt.
Sir, no doubt?
Yes, no doubt. These steps you need to follow.
What, sir?
These steps you need to follow. While implementing higher order MUX by lower order MUX, these steps you need to follow. Okay. Yeah. Okay. Completed.
Remaining
New response completed. Remaining, do you understood how I am doing?
yes sir.
Remaining Rubiadore, okay. Ammolia, Nellore. She came new. Ammolia. Hello. Ammolia came. Ammolia. Who is Ammolia? New. Shubhi Yadav. Leave the meeting. Okay. So completed. The response.
Your voice, sir.
My not voice is not audible.
Yes sir.
Hello. 1 second.
She came sir.
Hello. Yeah, Shrubi Yadav. Okay. Fine. Shall I move forward?
Yes sir.
Okay.
Yes.
1 second. Next, I want to implement 8 cross 1 mux by using 4 cross 1 mux. 8 cross 1 mux using 2 cross 1 mux. How to implement? How to implement? Tell me. First, what I need to do? First, what is first step?
Calculate number of marks.
So first you need to divide 8 by 2. So 8 by 2 means what is the quotient? 4. This will come in which stage? First stage. Okay, this will come in first stage. And next 4 by 2, that is equal to what? 2. So this will come in which stage? Second stage. Okay, and next 2 by 2, this is equal to what? 1. This will come in which stage? Third stage. Okay.
Total 7 marks sir.
Yeah, total 7 marks are required. So first stage you have 4 2 cross 1 marks. 4 2 cross 1 marks. So here 4 2 cross 1 marks. So this is first marks. Okay, so 2 cross 1 marks, second marks, 2 cross 1, third marks, 2 cross 1, fourth marks, 2 cross 1. So how many inputs are there total? So here I0, I1,
18 marks.
8 inputs, I2, I3, and next I4, I5,
I6
I6, I7. Okay, I6, I7. So I0 to I7. Okay, so common selection line, that is nothing but S0. S0 is the selection line. Okay, for all these muxes, common selection line. And these output is given to 2 more 2 cross 1 mux. Okay, this is first stage. In the second stage, you have 2 2 cross 1 muxes. 2 cross 1 muxes. Okay, so this is the 5th mux and this is 6th mux. Okay, so 2 cross 1 mux, 2 cross 1 mux. Okay, so this one is given to this one. Okay, and what is the common selection line?
S1
S1 is the common selection line, and this output is given to one more 2 cross 1 mux. Okay, so this is 7th mux. This is 7th mux, 2 cross 1 mux. Okay, and the selection line is S2, and the output is what? Y. Okay, So like this you need to implement. So if you see the if you see so selection lines, let us take the selection lines are what? S2, S1 and S0. S2, S1 and S0. Three inputs. How many possible combinations? 8 possible combinations. So 0 0 0 0 0 1 0 1 0 0 1 1 and so let us take this one 1 0 0 1 0 1 1 1 0 triple 1. Okay, so here if it is if it is S2 is 0, you are getting from where? S2 is 0. So suppose S2 is 0, S2 is 0, which muxes will be connected? Tell me, which inputs will be connected? Or otherwise I will see. So suppose if it is 0 0 0, so 0 0 0 means what? This is 0, this is 0 and this is 0. Okay, so when it is 0, I0 is connected, and this is 0, this line is connected, and this is 0, this line is connected. So y equal to what? I0. Okay, and when it is 0 0 1, when it is S0 is 1, this one is connected. Okay, and anyway this is 0. Okay, 0 and this one is connected. So that means I1 is connected. Now you got the concept how it is connecting? Huh? Okay, so if it suppose if it is like 1 0 0, which is connected? I4 is connected. Okay, so S2 is 1. Okay, S2 is 1 1 means this will be connected. Okay, this is 0 only and this is 0 only. Okay, this is 0, so that means this line is connected like this and this line is connected. So I4 is connected to output. Okay, suppose if I check the last case, what is the last case? Triple 1. So triple 1 means what? So S0 is 1 and this is 1 and this is 1. So this is 1 means which is connected? I7 is connected through this line. I7 is connected through this line. So do you understood how I am doing this?
Yes,
okay, so this is nothing but implementation of 8x1 MUX by using 2x1 MUX. Okay, in general you tell me, suppose if I want to implement 2 power n x 1 MUX by using 2x1 MUX, how many MUXes are required? Do you understood my question? Hello.
Second.
How many 2x1 MUXes, 2 power n x 1 so for 2, so to implement 2 power n x 1 MUX by using 2x1 MUX, how many 2x1 MUXes are required? Tell me. Suppose 8x1 MUX by using 2x1 MUX, how many MUXes you got? 7. Okay, previously you seen we implemented, what we implemented? This is nothing but 4x1 MUX by using what? 2x1 MUX. How many MUXes you need got? 3. So from this you tell me, in general, suppose if I want to implement if I want to implement 2 power n x 1 MUX by using 2x1 MUX, how many 2x1 MUXes are required? See here, from the concept itself it is there. Suppose here I implemented 4x1 MUX by using 2x1 MUX, how many 2x1 MUXes are required? 3 are required. Okay, and here I implemented 8x1 MUX by using 2x1 MUX, how many MUXes you got? 7, no? Suppose next I will implement 16x1 MUX by using 2x1 MUX, how many 2x1 MUXes are required? 15 are required. Okay, so similarly let us take 64x1 MUX is there. 64 cross 1 mux I need to implement with 2 cross 1 mux.
31.
How many are there? How many are required?
31, sir.
How 31? Here 16 cross 1 mux using 2 cross 1 mux. I got 15. 8 cross 1 mux by using 2 cross 1 mux I got 7. Here how much you will get?
63.
63, no? So what is the general formula? 2 power n minus 1. 2 power n minus 1. Understood? Suppose if I want to implement 256 cross 1 mux by using 2 cross 1 mux. How many are required? How many 2 cross 1 mux are required? 255. So what is the general formula? That means they will ask in the interview. So how many are required? So if you want to implement this many muxes, so 2 power n minus. In general, this is the general formula. So this is the formula. Okay, this is the formula. Okay, one second.